Hi everyone, my name is N. Vishwanath, Assistant Professor, EC Department, St. Martin's Engineering College, Dulapalli. Today I am going to discuss probability theory and stochastic process concepts. What is probability? What are the sample space, experiment, events and outcome, examples with problems? We are going to discuss this probability. So probability means it is a ratio of favorable outcomes to the total number of outcomes. So here favorable outcomes, for example, if you throw a die, if you throw a die, we will get outcomes 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So these are outcomes. So in probability, so we have to understand these are the technical terms. First one is sample space and experiment, outcome and event. So here, so if you throw a dice. So dice will have 6 phases, right? So these outcomes are represented by capital S, sample space. So these are represented in the form of a set. The outcomes of these dice are represented by 1, 2, 3, 4, 5, 6. So these are the outcomes of throwing a die. So this S indicates sample space. This S indicates sample space. First technical term, in order to understand probability, the S we need to understand. S is here sample space and throwing a die. So here throwing a die. Throwing a dice is an experiment. So this is very important in order to understand probability concept. So here throwing die, otherwise tossing a coin is example of experiment. In our daily life, we'll use this probability concept. So for example, today is cricket match is going on. So everyone will predict winning chances. The probability means here chance. Probability means uncertainty. So random in nature. So here experiment. So experiment means so some function, some work is going on, that is called experiment. So if you, in this experiment we'll get outcomes. We'll get outcomes. So these are represented by outcomes represented in flower brackets in sample space. So these outcomes mean, so for example, if you throw a die, so we will get 1, 2, 3, 4, 5, 6 outcomes. Next, very important technical term is event. Another one, event. So here event. So here what do we mean by event? Means the outcomes are represented in the sample space. This event is a subset of sample space. So for example, in order to understand event, what is the probability of getting odd numbers? Probability of getting odd numbers. So that is will indicate with the help of P of odd numbers, that is equal to so here what are the odd numbers? 1, 3 and 5. 1, 3, 5 odd numbers, and the probability of this odd, so here total number of outcomes in this event are 3. Favorable outcomes are 3 and total number of here outcomes are 6. Okay, this is what actual probability means. Probability means the total number of favorable outcomes and total number of outcomes. So your favorable outcomes are 3 and total number of outcomes are 6. So okay, this is equals to 1 by 2. So this is uh, called simple probability definition. So many examples we'll see, we'll use in our daily life regarding probability. So here probability plays very important role in research. At the same time, so many scholars they will use this. So here random experiment. So you can see. So in random experiments, we'll get random outcomes. So experiment means tossing a coin. In that tossing a coin, we'll get a sample space, experiment, outcome, and event. And very important one more example for understanding this probability: playing cards. A deck of playing cards will have in the total we will have 52 playing cards. In this 52 playing cards, if I ask what is the probability of getting king? What is the probability of getting king? So here, what is the probability of getting a king card? So here, king probability will indicate with capital P and king card. So here, total cards are 52. A deck of playing cards will have 52 total cards, and kings, I am asking king, how many king cards will get? So in this deck of 52 cards, so there will be four kings. 4 kings will have different shapes and labels will have this 4 king. This is the probability of getting king card. And if I ask probability of getting here a diamond king, probability of getting diamond king. So there will be only 1 out of 52 cards. Okay, this is the probability. This is a probability in playing cards example, probability calculation. So next coming to, so here events different types we have. This event is subset of this sample space, right? So here throwing a dice will get outcomes 1, 2, 3, 4, 5, 6. So here we can see, okay, this is a outcome of this sample space. Right. So here total number of this indicated by n of s is total number of outcomes 6. And so here I am defining event. So E1 I am defining, okay, there is a probability of getting. Okay, there is a probability of getting odd numbers. The probability of getting odd numbers I am indicating with E1, 1, 3, 5. This is subset of sample space. What is sample space? Total number of outcomes are represented in this flower bracket 1, 2, 3, 4, 5, 6. So this is your sample space, and total number of outcomes in this throwing die is 6, and getting even numbers 1, 3, 5. This is subset of sample space, and so here in this probability of getting odd numbers, total number is 3. And similarly, one more event we can also declare getting even numbers in this sample space. In this sample space, getting even numbers will indicate with E2. Okay, that is in flower brackets 2, 4, 6. 2, 4, 6 are even numbers I am indicating. So next we have so many types of events. Simple event. In the simple event, we will have one single sample point. For example, tossing a coin. So tossing a coin will get probability of getting head and probability of getting a tail. So this is indicated by 1 by 1 by 1 by 2. Probability of getting it. Okay, this is indicated by P of H. P of H is equals to 1 by 2. Similarly, probability of getting tail. Probability of getting tail will indicate with 1 by 2. So next, compound event. So compound event means, so for example, here we can take playing cards. So playing cards will have king card. For example, if you take king card, so king K denoted by in the card. At the same time, different shapes will have on that card, diamond shape, love and leaf, like that. So here getting king black and king red. So like that is a compound event. Similarly, mutually exclusive, otherwise disjoint event. So another event is mutually exclusive. So this is a event is said to be mutually exclusive or disjoint. There is no common outcome in these two events. For example, if we consider A event, B event, so there will be no common area. So this is a event, and okay, this is a B event, and this is simple sample space. So A event is different, B event is different, and there is no common outcomes in these two events A and B. So this is mutual exclusive. This is also called disjoint event. Another event is mutually non-exclusive events. Non-exclusive events. So there will be some common value in this event. The events which are not mutually exclusive are non-mutual exclusive. These are called joint. We can say joint events. So event A and event B. So this is event A and this is event B, and here we have common outcomes in these two events. Then they are called non-exclusive, mutually non-exclusive event. Next, independent event. Okay, this is also very important type of events. So here there will be no happening in these two events. They are A event, B event, each other independent to each other. Next, dependent events. So in these dependent events, they are said to be dependent. So one event depends upon another event. Okay, that is dependent event. And this is a classical definition of probability theory. There is a number of total favorable outcomes to the total number of possible outcomes. So with simple video, I am going to explain this one, so that we can understand this probability concept comfortably. The probability, so in our daily life we will use these are experiment, outcome, possibility, event and a sample space. We have discussed one by one in this one. This probability, here we can see possibilities. What are the possibilities? What are the chances? What are the getting outcomes? See, for example, if a student written exam, so here we will have two probabilities, passing and next failing. Next, tossing a coin, or throwing a dice. What is the probability of getting even number, odd numbers, like that. These are the possibilities of this experiment. Experiment means tossing coin, throwing a dice. The possibilities we will see one by one. Example, rolling a dice. Rolling a dice is a experiment, and possibilities are 1, 2, 3, 4, 5, 6. Right? So here common name given for this example, there is a sample space. Sample space is a one where a set of all outcomes are represented in an experiment. Right? So these are all possible outcomes, 1, 2, 3, 4, 5, 6. Throwing a die, these are all possible outcomes are denoted by capital S. Next, here sample space. Sample space. So here what are the count? Count is denoted by this sample space are 6. These are represented in flower bracket. N of S is 6 outcomes will get in this experiment. So event, specific thing we want. So that is getting even number, getting odd number. Next one more event, Ludo. So getting 3 on dice, getting 6 on dice, 4 on dice, 2 on dice. This is also very popular example for understanding probability events, and these are all. So here, see events, different types of events we have: mutual events, non-mutual exclusive events, simple event, and different event, independent events. Getting 3 here on dice, getting 6 on dice, like that. So here how the probability between event and event B. These are formulas used for this probability. Number of outcomes divided by total number of outcomes. So here, okay, this is a classical definition about this probability. So here types of events is, we have seen impossible events. So here you can see, okay, these are also different types of events. Impossible event, for example, if you throw a die, what is the impossible in this event? Getting 7, right? Getting 7 is not possible, right? So the die will have 6 phases. 6 phases having 1, 2, 3, 4, 5, 6 numbers. 7 is impossible, right? So this is impossible event. Sure event means, so whichever is going to be possible throwing. So what is that sure event? If you toss a coin, getting head is a sure, getting a tail is a sure event. Independent events. So independent events mean the events which does not depend on each other. So dependent events, mutual exclusive events, we have seen this. So playing cards, in example, we can understand what is the probability of getting. So here we can understand clearly independent events, dependent events, like that. So getting queen card, diamond shape, leaves, love shape is a entirely independent events. One more. So here getting particular value and a particular diamond shape will get. So here independent events and dependent events. For example, one more example I will discuss with you, that is, for example, so axioms of probability. Axioms of probability, I will explain. These axioms very important for understanding this probability. Probability value, probability of event A. Okay, that is always greater than 0. Probability value will be always greater than 0, and probability value is non-negative. Always it is a non-negative number, and probability of getting in unity, that is probability of whole set is a unity. So complete set, if you take the total, if you sum, you will get 1, and probability of event A intersection B is null, means we will get probability of A union B is equal to probability of A plus probability of B. Okay, this is regarding probability axioms, properties also you can see, and conditional probability. Next one, very important concept in probability, condition. So these are all used in picking a particular color ball, games, otherwise in distribution of particular items, things. So there we'll use this conditional probability. So in a box we have some resistors. In that one, picking particular resistor, 5 kilo ohms resistor, 10 kilo ohms resistor. If you want to pick, so we'll we'll use this conditional probability. So here we'll say independent trials will consider NA, NB, NAB. Okay, these are all a number of events in this one, AB and AB occurring respectively. So here probability of getting A, particular condition we are getting, so we'll indicate with the probability of A event. So here that is NA by N, and probability of B getting in this NB by N, probability of AB getting NAB by N. So here NA, what is this NA? This is probability of getting event A outcomes in a event A. Similarly in AB event denoted by NB and NB NAB. Now this is a ratio. Conditional probability is ratio of NAB by NB. So here NAB is what NAB by total number of outcomes N, and NB event probability favorable and total number of outcomes. This total number of outcomes N, capital N, numerator and denominator cancel, means probability of A by probability of B. Okay, this is the probability of AB by probability of B. Here probability of B not equals to, the probability of this is not equals to 0. Okay, this is the probability. This is also indicated conditional probability is indicated by probability of A by B. Probability of A by B is this is probability of AB by B. For example, this can also be possible probability of B by A. Probability of B by A is probability of AB by probability of A. So I said this probability of B is not equals to 0. In order to get conditional probability, denominator event denominator value should not be equals to 0. If you get that, so your conditional probability will not tally, we will get infinity. So here conditional probability here also we have some properties, axioms like basic probability. This probability of A by B. So A is one event, B is another event. The probability of A by B conditional probability formula is probability of AB greater than 0 and probability of B greater than 0. This is always greater than 0. Probability value will be always greater than 0. Next, your probability of omega by B, particular event. Probability of omega, that is omega B is equals to B. That is probability of B by probability of B. This is equals to 1. Here A intersection C is 0, means independent events value is always 0. Okay, these are the some properties of conditional probability. This always is equals to 1. So here these properties are used for calculating conditions of particular event occurring. So here I want to explain this probability with simple problem. For example, two dice are thrown. Two dice are thrown. What is the probability we'll get? What is the probability we'll get? We'll see one by one. So here this probability, simple problem I will explain and I will move forward. So here two dice are thrown. What is the probability of getting? Probability of getting same numbers, on two dice. What are the outcomes? What will be the sample space? S is equals to sample space 1 comma 1 and 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. Okay, these are the possible outcomes throwing 2 dice an experiment. Here S is a sample space, right? These are all possible outcomes. What is the possibility here? Here getting same numbers on 2 dice. Same number. If you throw 2 dice, the 2 dice should show same number. So what are the possibilities outcomes means 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. So now what is the total probability of total probability of throwing 2 dice, is equals to 36. 36 total outcomes we will get. So now this probability of getting same numbers on 2 dice, that is equals to total how many outcomes in the sample space? Same numbers facing 1, 2, 3, 4, 5, 6. That is total favorable outcomes are 6 and total number of outcomes are 36. Okay, this is the probability. Probability value always lies between 0 and 1, right? Okay, this is equals to 1 by 6. Total number of getting same numbers, this. Like that, so many examples we can consider. What is the probability of getting 7? What is the probability of getting 7? So 2 dice are thrown, means what is the probability of getting 7? So first we have to understand this outcomes. What are the possibilities? 1 comma 6 and 6 comma 1. Similarly 3 comma 4 and 4 comma 3. Right? So what are the possibilities again? 5 comma 2 and 2 comma 5. Okay, these are the possible outcomes. 1 comma 6, 6 comma 1, 3 comma 4, 4 comma 3, 5 comma 2, 2 comma 5. So how many total outcomes here? Here also again 6. So total favorable outcomes 6, total outcomes 36. Again this is equals to 1 by 6. So here this is about calculating probability and using conditional probability, and we will see. So one more important theorem we will discuss, and we will try to solve simple problem related to this. Total Bayes theorem. Okay, this is about Bayes theorem. So Bayes theorem, very important theorem in probability concept. Okay, this speaks about a probability of a event occurring in random number of events. So here we will consider one event A and another event B. In a sample space we have n number of events, right? 1, 2, 3, 4, so on, n and m. This event, if we consider, what is the probability of getting only particular event we want to calculate, we have to use total probability. And what is a defective? What is the defectiveness in particular experiment, in order to see, we have to discuss this Bayes theorem. Very, very important Bayes theorem. So the purpose of Bayes theorem is to calculate the particular thing, defectiveness, otherwise particular same thing, in order to detect, we have to use this Bayes theorem. So here, for example, if we consider two boxes B1 and B2, and B1 having 100 items, bulbs, another B2 having 200 items, the first box having 15 defective, and second box 5 defective. So in this picking particular defectiveness, we will calculate using this Bayes theorem. So first defectiveness indicated by capital D, and probability of defectiveness in B1 is 15 by 100, that is 0.15, and probability of getting defectiveness in second box is 5 by 200, that is 0. Now probability of getting random B1 and B2, that is 1 by 2. Okay, this is the probability of getting our total defectiveness in box B1 and B2. Probability of D by B1 into probability of B1 first box, and probability of defectiveness second box, and probability of B2. So this is having 0.875 value probability, and percentage of defectiveness is here it is 90%, you can see. So like this probability plays very important role in our daily life. So many areas will use this probability concept. So today we have discussed this probability concept, sample space, experiment, outcome, and events, different types of events, and how to calculate probability, and what is the probability getting particular value. With this I conclude, and thank you very much.